In this video, we'll look at some Venn diagrams. So Venn diagrams are a visual way of representing various sets, and in particular they're really good at representing set operations that we looked at in the few videos ago in a really intuitive way. So here's a Venn diagram of two sets, A and B. So look at the elements of a Venn diagram. There is circles which represent some of the basic sets, so A and B, and they always cross over. They must cross. We also have this box around A and B, and that represents the universal set, the world we are living in. Also, A, B, and the universal set are all labelled, and that's really important, they're all labelled. How do we use Venn diagrams? Well, we shade in the various sections of this to represent the set we are concerned with. So for example, if we were concerned with the set A, we would shade in the set A, which is that circle which represents all of the set A. There are two sections to this. So you can see there's the bit of the set A which is inside B and the bit of the set A which is outside B, and they represent the intersection and A difference B respectively. What's really nice about Venn diagrams is that you can see how everything sort of interacts with each other. So like I said there, the intersection of A and B plus the set difference of A set difference B, you can see that they don't cross over, they must be mutually exclusive, and you can see that when you take the union of them, you get A. And that's why I'm saying these are really intuitive ways of showing sets. Let's show some more examples. So for example, if we would look at set B, we would shade in all of the circle that represents B. These are really useful for showing set operations as well, and especially combinations of set operations. For example, here is, we've shaded in A union B. All those bits of the diagram which are represent things that are in both A and B or both. Here we've shaded in the intersection of A and B. Here we've shaded in not A, and that now you can see why representing the universal set here is really important. This is not a Venn diagram unless the universal set is there, and if the universal set wasn't there, you could not represent the complement of A, or not A. Similarly, the complement of B. The complement of the union now, that's what I mean by combining set operations. It's very intuitive. We knew what the union was. It was everything in both the A and B circles. So the complement is everything that's outside of that. Similarly with the complement of the intersection. Set differences then, we can see that we are taking A set difference B is all the section that represents A, but not the section that represents A inside B, and similarly for B minus A. And this is really nice to show that the set difference operation is not symmetrical. A set difference B is different to B set difference A. You will also see stuff like this. So here's a Venn diagram of three sets, A, B, and C. That's completely fine. But you will see, for example, people writing elements of sets on the diagram to represent which bits they are represented in. So for example here, the number 7, right in the middle there, it's within the A circle, it's within the B circle, and within the C circle. So it's a member of A, B, and C, and therefore it's a member of the intersection of all of them. -5 there is a member of B and C, but not a member of A. So it is a member of the set B intersection C, but it's also, because we know it's not in A now, we can also say that's a member of the set B intersection C minus A. So this can be a useful way to represent where elements lie in sets. Here's a really nice Venn diagram that I found on Wikipedia. I really enjoy this one. It's a 3-set Venn diagram of all the symbols used in the Latin, Greek and Cyrillic alphabets. And some of these symbols are used in both the Latin and Cyrillic alphabets. Some of them are used in both the Latin and Greek alphabet and so on. Some are used in all three. And this is a really nice way of representing that. And I like this because, again, it shows that sets don't have to just contain numbers. They contain any sort of objects. Here we've got characters of various alphabets. And it's just a very nice diagram. Some rules for Venn diagrams then, I've mentioned these before. So the segments must represent sets. If they represent anything else and not sets, then this is not a Venn diagram. The segments must be labelled, because otherwise we don't know what we're looking at. The elements of the sets may be shown, but they don't have to be. Here's an important one though. All possible intersections must be shown, even the empty intersections. So for example, if we know A and B are mutually exclusive, it's very tempting just to draw them apart. But actually we must show the intersection even if that intersection is empty. And because of that rule, because we must show all the intersections, we can't really show more than about 3 sets. We can just about do 4 if we represent the sets as ovals or ellipses instead of circles. We might be able to do 5 if we slant them in a certain way, but reasonably we can only have Venn diagrams of 3 different sets. Definitely no more than 5, because every intersection must be shown. Here's some examples of Venn diagrams I've seen on the internet which are not Venn diagrams. They break the rules. There's a trend on the internet of having humorous Venn diagrams. So for example here, I'll let you read that, but you can see that what this is trying to say is that both toddlers and bad dogs bite people, both toddlers and prisoners survive on bread, and so on. This is not a Venn diagram though. Why? Because the circles do not represent sets. For example, that label toddlers, is that an element of a set or is it a set? If it's an element of a set, then it doesn't make sense to go bites people is also an element of that set. What's the set that contains both toddlers and bites people? If toddlers is the set, then what does bites people represent? Bites people is not a toddler. So these are humorous, but they are not Venn diagrams for those reasons. Another humorous one I've seen is this, which is a Venn diagram representing mythical creatures. And what I was trying to show you is, for example, the pink circle is the humans, the green circle is horses. So the intersection of humans and horses is centaurs. And this is very close to a Venn diagram. There's a few reasons why it's not. So humans and horses are sets, great, but the element centaur is neither a human nor a horse, so it cannot be in the intersection. The other thing that's wrong here is that not all intersections are shown. For example, the intersection of dog and horse is not shown, and the set dog is there 3 times. Elements are in there more than once. We know these can't be sets. If, however, we do have what we think is a Venn diagram and it follows all the rules except that not every intersection is shown, the empty intersections are not shown, we call these Euler diagrams. And these are also really, really useful diagrams. They're just not Venn diagrams. Here's one that I remember I drew a few years ago to try to explain to some some friends in Africa how the British Isles and the United Kingdom is made up, and the Euler diagram was the best way of showing this, because what was the important information was which intersections were empty, and that's why the Euler diagram was useful in showing that. But this is not a Venn diagram. So if I ask you to draw a Venn diagram, you must show every segment, every intersection.